Soil organic carbon makes up 50% of soil organic matter and is thus a fundamental soil quality indicator. In this work, we have studied whether the organic carbon content of soils can be detected using hyperspectral data from the PRISMA satellite of the Italian Space Agency. PRISMA is part of a new generation of hyperspectral spaceborne sensors being launched in recent years. Its sensor has a 30-meter spatial resolution and can sample 234 spectral bands in the 400 to 2500 nanometer range. It can also produce a 5-meter resolution panchromatic image. PRISMA data products include level 1 top of atmosphere radiance and level 2 bottom of atmosphere reflectance. To model the relationship between the soil spectrum and the organic carbon content, we have attempted to implement a neural network. We chose a standard multi-layer perceptron architecture and optimized its hyperparameters by training and testing it over a dataset of soil spectra and organic carbon values obtained from the European Lucas topsoil database and run to a radiative transfer model to obtain top of atmosphere spectra. The optimum configuration yielded a 0.8 R² coefficient of determination. We then applied this configuration to PRISMA data. We used as study area the Emilia-Romagna region in Italy, which is covered by 35 PRISMA images, of which 17 over the area surrounding the Iolanda di Savoia municipality. We used land use data and the NDVI index to filter out non-bare soil pixels from the PRISMA images. The carbon values we associated with the PRISMA soil spectra to obtain the neural network training and test dataset were initially taken from a set of 161 soil samples collected in the Emilia-Romagna province of Ferrara. However, these were too few, and in any case would have been unsuitable, since PRISMA has a 30-meter resolution, but organic carbon varies over far smaller distances. We thus opted to use the topsoil organic carbon map of the Emilia-Romagna lowland regions provided by regional authorities, which has a lower 500-meter resolution, after resampling to compensate for the resolution difference. Trained and tested on the same PRISMA image, the neural network can reproduce a visually similar copy of the carbon content map. The coefficient of determination never exceeds 0.65, however, and reaches such values only if the image contains areas with high levels of organic carbon. Most importantly, a neural network trained on one image yields very poor results when applied to others. We have thus so far failed to effectively model the relationship between soil spectrum and organic carbon content. The main reason is the lack of suitable organic carbon data. We have already highlighted the problems of the soil sample dataset, and as for the Emilia-Romagna organic carbon map, it had a 500-meter resolution compared to PRISMA's 30 meters, and it may not be possible to resample it correctly. We thus propose to obtain suitable data by carrying out a new soil sampling campaign. The sampling locations will be chosen within the bare soil pixels of a given PRISMA image. Each chosen pixel will be accurately located using the PRISMA panchromatic image. And each sample will be composed of subsamples collected over the pixel 30 times 30 square meter area, so as to compensate for the spatial resolution problems of the previous dataset. About 100 samples should be sufficient to obtain some preliminary results.